you are going to differentiate y here with respect to x, and again, whenever you are going to differentiate it, make sure it is tidied up in a favorable format first. So y can be written down as x and then x minus 2 power of negative 1 over 2. Then we can differentiate it by using the product rule, or you may use quotient rule. Just make sure you can memorize the formula. And then we differentiate the first one, keep the second one. We keep the first one, differentiate the second one. And don't forget, we still need to differentiate what inside, so it's give you 1 this time. Tidy up first. Now we are going to take out the like terms. We are going to take out the common factor with the lowest power. So this time we take out x minus 2 power of negative 3 over 2. The first term will give you x minus 2 power of 1. And then you may extract 1 over 2 also. So we have 2x minus 4, and then we have 1x. So it is x minus 4 at the back. You may write in this format. In part B, they give you a tangent pass through a certain point. We have to find the slope of this tangent. This is the most advanced type question involving tangent. It's because they don't give you the point of contact. So just roughly draw the graph. X must be larger than 2, and I have no idea, maybe it's look like this, I'm not sure. But anyway, they give you 1.90. And then there is a tangent pass through this point. And our target is to find out the slope of this tangent. Just like what I mentioned, the most difficult thing is we don't know the contact point. That's why we are going to let the point of contact. But one thing very important is you don't use two different unknowns to represent this point of contact. It's because you already know this point is lying on the curve, is fulfill this requirement. So you should just use single unknown to represent it. That's why you can solve something later. On this curve C, when x is equal to h, then y should equal to h divided by square root h minus 2. So this is h over square root h minus 2. And now we consider the property of tangent. The slope here and the slope of this curve at this moment should be the same. In other words, that means the slope of our tangent is equal to dy dx when x is equal to h. We are going to rely on this equation. Slope of tangent is equal to dy dx when x is equal to h. So left hand side, we try to focus on the straight line. It's passed through these 2 points. So the slope is the y difference minus 0 and the x difference. I express it in terms of h. At the same time, right hand side also, we have dy dx. We have all the slope at different points. We are considering at a single point, that means the point of contact. We have h minus 4 over 2 times h minus 2 power 3 over 2. Even it's look complicated, but this is an equation involving one kind of unknown only, so maybe we can solve it after simplification. H, and then this is h minus 2 power negative 1 over 2 times the denominator on both sides, so we have 2 and h minus 2 power 3 over 2. H minus 4 times h minus 9. So this becomes 2h, h minus 2 power of 1. H squared minus 4h, h squared minus 13h plus 36. It's become a standard quadratic equation that we know how to solve. H plus 12 and also h minus 3 equal to 0. So we have h equal to negative 12 or h equal to 3. Again, we have two possible solutions. Then we check, do we need to reject anyone? We find that x is always larger than 2, otherwise what inside the square root will become negative and create imaginary part. So this is rejected. We find out that h is equal to 3. So the point of contact is 3, and then 3 divided by square root 3 minus 2. That means 3, 3. This point is 3, 3. Then we can get the slope because we already know exact position of 2 points on the tangent. Therefore, the slope of tangent is equal to delta y 3 minus 0 over delta x 3 minus 9. Negative 1 over 2. We answer the question.